When you take a sip of water on a hot day, you're probably thinking more about how refreshing it tastes than any pollution that might be in that water. Similarly, I'd venture to guess that a fish in the Iowa River is thinking more about its next meal than about any chemicals that might be surrounding it. I don't know, I'm not a fish. But in any case, with the abundance of chemicals that we apply to our agricultural landscapes, as well as residential and commercial areas that tend to wash off and enter our lakes, rivers, and streams, some of which are drinking water sources, it's really important that we understand how these chemicals behave in the environment. I look at this issue by studying how vegetation and chemicals interact. That might be aquatic vegetation, the crop plants themselves, or plants in our residential and commercial areas. In all these cases, I want to know, how is the vegetation interacting with the chemical? Is the chemical being taken up by the plant, stored in the plant, perhaps presenting an exposure risk to someone who eats that plant? Or is the plant breaking down the chemical into less toxic forms? I specifically look at these kind of processes with two groups of compounds. The first is neonic pesticides. They're the most commonly used pesticides in the world currently, and they do tend to wash off into our lakes, rivers, and streams, including here in Iowa. I found that a common aquatic plant, duckweed, and its associated microbes working together remove these pesticides from water. And while we don't know all the steps involved in the removal, we do know that known more toxic compounds that sometimes form from these pesticides are either not present or present in very low quantities when you treat them with duckweed. So this is a previously unknown and exciting way to remove these pesticides from our waters. The other group of compounds I study are applied to the side of buildings to prevent scum from growing. But some of them wash off during rainstorms, entering stormwater that flows across the landscape, perhaps into your garden with your tomato plant. I've shown that at least in a lab setting, with sterile plants, so no microbes this time, these chemicals are rapidly taken up into the plant. And I'm now working to determine if the chemicals are broken down further, perhaps detoxifying them, or if they're stored in the plant, again presenting that exposure risk I talked about to you eating that tomato, or maybe a caterpillar who gets to it before you. In any case, I hope you can see that my work aims to protect drinking water sources, food safety, and environmental quality. Thank you.